No, I was missing 6 as of Friday. I'm down, I had all 10 walking in here, so. It was the last class, one of them turned down. Alright. Okay, today, let's walk through a couple notes here. Okay, the part that we're covering here today, we have reference angles, we have positive negative sign charts, we have the trig functions themselves, and we have coordinate plane stuff. These are all the things we need to cover today. I have about 3 or 4 examples picked out, one of which we'll kind of cover in 2 different spots, but this is kind of our goal. There is some things here that we're going to get that we're going to need to put on the property sheet, and I'll explain the property sheet as we go, and I'll hand it out here in a minute, once we get to the appropriate time when you need it. The first part we don't need it, so that's why I'm not handing out yet, because people will just be looking at it, they wouldn't be paying attention. The first thing I want to talk about is called a reference angle. Okay, a reference angle is when you have some form of an angle that is larger than obtuse. So it's non-acute angles. Okay, what I mean by that is when you're given a non-acute angle, okay, on a trig function, let's say like 150 degrees, something kind of strange, you are allowed to take that non-acute angle and convert it. You're allowed to convert it to something that is useful. So we are going to convert to a special angle. So what I mean by a special angle, it's going to be a part of the special triangles. So it's going to be an angle we can actually use. That conversion only works in certain cases. The later sections we're going to learn, and that's why I'm going to give you a property sheet. When I give you just a crazy obscure angle that there's no way to use a reference angle, there is a possibility that we can change it, and that's the stuff we're going to learn throughout Chapter 5. Chapter 5 it's intense. Like I kind of warned you that starting like Chapter 4 kind of starts off nice and easy, and then Chapter 5 is just a different animal completely, because there's only a select few sections in Chapter 5, but my God, they're hard sometimes. So I just want to make sure you have a formula sheet, and it makes it way easier. You don't have to memorize everything like I had to. You can actually take time and like look at the sheet and mark things on there that will allow you to have kind of special occasions. You can write something on the property sheet that will make little references, so you note to yourself. But let's talk about like a reference angle. Let's talk about like if I want to find the cosine of 150 degrees. Let's say I'm doing a trig function. I want to evaluate a trig function, right? That's still the point of what we're trying to do here. We're trying to evaluate trig functions. But for random obscure angles. In our case, we're doing like obtuse angles like I talked about yesterday, reflex angles. I think the angles I picked yesterday, I think I picked like a 240, that's a reflex angle, right? It's past 180. But we can actually convert this angle to something smaller by using special triangles. So 150 degrees, if we're on a coordinate plane, remember this is 0, this is 90, if we're going counterclockwise, this is 180, 360, 270, 360, all right. So, and then you can keep spinning. But the idea is that 150 is over here. That's a 150 degree angle, right? You started in the first, you open up counterclockwise until we get to 150. And how I know that, I didn't get quite to 180, so it stopped. It was past 90, not quite to 180. Now, this angle, even though this is your 150 degree angle right here, a reference angle is anytime you have a very large angle and you bring it back to the closest x-axis that's closest to it. So, the conversion here, and I agree, the conversion is we have to bring the angle back to the x-axis. And it has to be the closest x-axis that you're near. So like in our case, we're going to bring this thing straight down, and we're going to make a right triangle out of it. That's how you make a reference angle. And the reference angle that's in question is this one. I'll use alpha as my angle. And that angle is the reference angle. That would actually give you a very similar answer on a calculator that 150 would be. Now I already heard what it is. How you actually find this, you take the 180 and you subtract 150. You just put it in order so that when you subtract you get a positive angle. So in our case, when I subtract that, that's a 30 degree angle. So right here, that alpha is now 30 degrees. That's the angle I wanted. That's it's a small angle, it's acute now, we made it small, but it's also a special angle because it's in a special triangle. So this is a 30, 60, 90 triangle, and I can fill in all the numbers I need to because of the 30, 60, 90. If you don't remember the 30, 60, 90 triangles, that's what this property sheet will help you out with. The special triangles are the opposite side of 30 is 1, the opposite side of 60 is root 3, and the side opposite of 90 is 2. Now, one of these numbers is negative, because you're in the second quadrant, right? We still have to worry about quadrants and positive negatives. Right? That's something that we need to worry about. So, on this particular problem, where are the negative numbers? Which number is negative up here? Root 3, yeah. How I know that? As you go left on the x-axis, you get negative numbers. If you're going up, that's positive. The hypotenuse is always positive. You don't have to worry about that. So now that we're here, now that we have my triangles set up and we plugged in all the numbers, and again, I'll put those special triangles on the board here in a minute, so you can see kind of where I'm getting this 1, root 3, and 2 thing from. Now that I have that, I can fill in like where the adjacent side is, where the opposite, where the hypotenuse is. I can fill those words in. So now I can find what I needed to. I wanted to evaluate this trig function. I want to know the answer, the exact answer for the cosine of 150 on your calculator without giving me a decimal. So the exact answer without a calculator is doing the cosine of 30. These would actually give you a very similar answer. The only difference would be a positive or negative sign. That'd be the only difference in answer. But the numbers would be the exact same because of the reference angle. So now, what does cosine stand for in SOHCAHTOA? What is the ca part of SOHCAHTOA?
Opposite or adjacent over hypotenuse.
Yeah, so cosine of an angle is adjacent over hypotenuse. That's what that part of SOHCAHTOA stands for. So you do need to know that little acronym, SOHCAHTOA. Since we're doing cosine, we're doing the ca part of that formula. So on this triangle, we're using the 30. The adjacent is root 3, the hypotenuse is 2. So my answer would be negative root 3 over 2. And that would be the exact answer that I'm looking for. I think there's only a select few calculators I've seen in this room that can actually give you that. Okay, I think yours can, which is kind of nice. It says certain Casios can. A version of yours, Sam, a version of yours can do it as well. It'll give you like the exact answer, like in fraction form, which is kind of cool. You can see that. But certain Texas Instruments can't. Now, I don't know what version you have, because there's some newer Texas Instruments that can.
TI-30 at
Okay,
6X Pro.
That's the one. That's the one. So that's the new Texas Instrument one that can do it. I know certain Casios can't do it because they had certain versions that it'll program where it spits out fractions, which is kind of nice. But that's the answer I'm looking for. That is evaluating your trig function, but using a smaller angle. Now, obviously, looking at this problem, there is a ton of math that's involved here. Because if you've never seen this before, obviously reference angles, bringing it back to the x-axis, making smaller angles. Special triangles. You need to know both special triangles. So I'm going to put these on the board. Okay, these are the ones you need to know. We can draw these any way you want. I'll do a couple more examples today. So this is the 30, 60, 90 triangle. Opposite of 30 is 1, opposite of 60 is root 3, the opposite of 90 is 2. And however you're going to draw, I'll show you another example here in a minute.
Wait, are these on our sheet?
Yes, this is something we're going to write on the sheet itself. So this will be one of the first things you need to put on that sheet. That's why I'm going to draw them up here. The 45, 45, 90 triangle, which is 1, 1, root 2. And again, why these are the weird numbers? Because they follow the Pythagorean theorem. The Pythagorean theorem, if you actually do a squared plus b squared equals c squared, it actually makes everything work. Okay, but again, these are the special triangles you need these. Now I'm going to hand out that property sheet, and you're going to need to put them, and what I'd recommend is that there's one of the sides that has a little more room than the others. It's the side with the big unit circle. You could put those special triangles maybe on the bottom, but make them big enough you can see it, because we're not going to put too much stuff on here because there's already a ton. Now they're a little blurry, apologies. It's kind of hard printing on these printers that we have at the school. They're not the greatest quality for Word documents. But if you check my website, I'll have a different copy. It'll look probably different than this. It's just like, I think there's just only a couple words that aren't on here. but it's a little more clean in case you need to print it home. But you need to draw these special triangles on this page. This is one of the things you can add. Because nothing's more painful than, you need a special triangle and you can't remember what numbers go where.
That would be just an
What the
misfortune.
heck?
It would be done. Tons of different things on here. Now, obviously, don't be overwhelmed. I will kind of point out things you need. We'll highlight, we'll put box around things you're going to use. And we're going to use this over the next couple chapters. Don't feel like it's like a one section and done kind of thing. We're going to use this throughout the year. So, like, especially when we get to like the semester test, this is a really nice thing to hold on to. Okay, it is helpful. Now, on the unit circle side, that's the side with the big circle on it, you'll want to draw these triangles. You can put them on the top or the bottom. You can draw them pretty big, you can draw those somewhere on there and label the walls. There's other things we're going to add here in a minute, but that's one for sure. It's like, I know most people have it kind of memorized usually if you've seen it a lot, or if I have it on the board, they just look up, but it's nice that it's on here in case you're at home and you're trying to figure it out. Now again, the goal today, I said I was going to do about 2 or 3 problems and then I'll give you some time to work. This is one of them. That's one of my 2 or 3 that I want to talk about reference angles so you can see how we can evaluate. The other things we need to talk about, we need to talk about positive negative charts, because I've been talking about positive negative numbers when we start putting things on the coordinate plane. Certain positive negatives go to places. We're going to do another example of that. And then we'll talk about, how to evaluate trig functions a little more. I'll do another example here in a minute. Okay, so far so good?
Yeah.
Okay, now, before I do my next example, like evaluating trig functions, doing the same thing we're doing here, because I had 2 or 3 picked out, we need to get one more chart put on your notes. One more chart. It's called a positive negative sign chart. It'll help you to figure out where positive negative numbers need to go. Now you're probably thinking, word I already know. It's a little bit different than you think it is. So let me get rid of this, and we'll come back to this whole reference idea. I'm not getting rid of this. So I'm going to leave these words on the board because we're going to use this here in a minute. We're going to do this conversion stuff, but you need this next chart somewhere in your notes.
Oh.
Okay,
Like on this sheet thingy?
yeah, so you're going to want to put it on that thing. I would say put it on the unit circle side, maybe near the top where the unit circle is, like up here maybe, somewhere up here. And it's just an easy little chart. It'll help you memorize if your answer is supposed to be positive or negative, so you don't have to worry about the whole negative things before the end. Okay, so this is the positive negative chart. Positive negative sign chart. Now again, we're going to be looking at some other stuff later. We have a couple more charts we're going to be adding here and there. But for this positive negative chart, we're going to fill in where if you're doing a trig function, like tangent or sine or cosine or cosecant or cotangent, and you're trying to find a specific angle, like let's say you're doing 150 or you're doing 310, you're doing weird angles, right? How do you know what your answer is going to be before you start? Like, is it going to be positive? Is it going to be negative? What would tell you that? So if you're in the first quadrant, so this is the first quadrant, right? You're in the first quadrant. All trig functions are positive here. So no matter what angle you have, if it was a 30-degree angle, if it was a 72-degree angle, whatever trig function you're taking over that angle, it will be positive if you're in that first quadrant. That's common sense, right? Because what are both numbers in that quadrant?
Positive.
Positive. When you go right and up, positive numbers up in that quadrant. And we'll look at an example of that here in a second. If you're in the second quadrant number 2, because remember that's counterclockwise, right? That's quadrant 2. Sine and cosecant are positive. So if you're doing let's say you're doing the 150 degrees I just did a little bit ago. That's in the second quadrant. Sine and cosecant, if you were to evaluate them, your answers would actually be positive on a calculator. So if you did sine of 150, it would give you a positive answer, a positive decimal. Again, we'll explain why here in a minute. You'll see it from the answers. If you're in the third quadrant, If you're in the third quadrant where like a ton of numbers are negatives, right down here, tangent and cotangent are positive. Bless you. Bless you again. Tangent and cotangent are positive in the third quadrant. So if we're doing like, let's say we're doing a 210 degree angle, like that's in the third, tangent would actually be positive at 210, whatever the fraction is. This is actually a positive answer. And the fourth quadrant. What are my last two trig functions? Yep, cosine and secant are positive here. That's your positive negative sign chart. You need it somewhere on your little graph. It's not very big, you know, you can put it in a little corner of the thing, but it will help you if you know before you start the problem, is my answer going to be positive or negative? So maybe you don't need to worry about filling in negative signs like I did in the last round. Like I was trying to figure out, okay, you know, where negative root 3 was. I didn't need to worry about that. Because you can find your fraction, your answer on the problem, and then just look at this chart and go, oh, it was supposed to be negative, and you just throw a negative sign at the very end. You could do it that way. So you never have to worry about positive and negative numbers. So maybe that just makes it easier for you. But this is definitely a chart that makes sense once you see it in action. Like why I would have that. And why you'd use these triangles to help you out. Okay, so let me give you an idea. Let me give you an example of what I want. Okay? Let's say I was doing tangent. Say I'm doing tangent of, I need an angle that's in the book. Let's go tangent of
78. 13. 39.
27.
0.00001.
do tangent of 4 pi over 3.
7.
4 pi over 3.
That is almost the number that I said exactly.
Okay. All right. Now, I want to know the exact answer for this trig function. I want to evaluate it at this particular angle. So, first, convert it. Now, here's the good news. You have a little property sheet in front of you, correct?
Yes.
I would like you to look at the big unit circle on that chart. The big unit circle. Okay, the big circle that you're looking at.
Oh, sure.
4 pi over 3
240 degrees.
is on that chart, and it's, say it again?
240 degrees.
240. The unit circle chart that I provided you will convert major angles from radians to degrees for you without having you do that whole 180 over pi thing. It will help you convert. And the angles that are on the unit circle, this big circle here, are the ones that I'm trying to use today. I'm not trying to venture off these, so I'm not trying to do like a 72 degree angle. I'm only trying to do ones that make these numbers, because these numbers refer back to the special triangles. They make really nice numbers, and I'll show you here in a minute. So Reese, you even said it. What was 4 pi over 3 according to that?
240 degrees.
240. Okay, so 240. All right, so now, if we're going to draw 240 degrees, you're in the third quadrant. So if you're looking at the unit circle, you're down here at 240, okay? Again, I'm just drawing that very, not accurately, but that's 240. So that's going this direction, counterclockwise, 240 degrees. Now, doing a reference angle, like we were talking about earlier, you bring it back to the x-axis. And so you take 180 degrees, and you subtract your 240 degrees. And that gives you a 60 degree angle in that quadrant, because 240 minus 180.
Oh, yeah.
That 60 degree is my reference angle. So what I'm telling you right now is that the tangent of 240 on a calculator would give you the same result as the tangent of 60 on a calculator. It'll actually give you the same result, positive or negative, doesn't matter. The digit will be the same, because that's a reference angle. It brings it back to the x-axis. So now, do you agree that that's a special right triangle? It's a 30, 60, 90 triangle. Because remember, on a right triangle, you have a right angle, but the other two angles have to add it to be 90. So that's why I know it's 30, 60, 90. So I fill in all the numbers. The side opposite of 30 is 1. The side opposite of 60 is root 3. The side opposite of 90 is 2, according to this
Or
picture.
that is depicted as convenient, because 60 degree side is shorter.
Say it again?
The way you drew it.
Yeah, it's not drawn on scale, obviously. Obviously. But anyways, so I filled in my numbers. Now, certain numbers up here are negative. If you don't want to worry about that, don't worry about it, because we can always look at this chart to figure out if my answer is going to be positive or negative here in a minute. In fact, what quadrant am I in? Third, so what is tangent going to be?
Positive.
It's going to be positive. My answer is going to be positive in the end. I know that. So whatever this fraction is going to be, it's going to be a positive fraction. Now, I want to explain why it will be positive. Because in the third quadrant, the 1 was negative and the root 3 was negative. You're going to the left and down. Both of those numbers are negative.
The negatives make a positive.
Yeah. And so when you set up tangent, if you don't know, for the function for tangent, like if we're doing SOHCAHTOA, it's TOA. So that's opposite. So tangent is opposite over adjacent for whatever your angle is. Well, on this 60-degree angle, because that's my reference angle, this is the opposite wall, this is the adjacent wall, and this is the hypotenuse. So doing tangent of 60, I'm using negative root 3 over the adjacent wall, which is negative 1, and do you see what happens to the two negatives?
They disappear.
They disappear and turn positive.
Yeah.
And so this right here is my answer on that problem.
Why can't you just do the math and get 1.73?
Okay, because 1.73 is, the decimal approximation of the square root of 3. But I want the exact answer, not a decimal. So I want to know exactly what answer it is.
Can we just say root square root of three?
You can just say square root of 3, but I don't want 1.7 blah, blah, blah.
1.732.
I want the exact answer. Okay, I know this is tough. This is what the second day of us actually learning how to even attempt to do bigger angles other than, small angles. It really requires super definitive knowledge of the special triangles, know how to set them up. It takes a lot of knowing where negative numbers go and that positive negative sign chart, just to common sense it when I'm done. Okay, questions, comments? I'm gonna stop there. I'm only gonna do 2 problems today. So you have the rest of the time today to work. Don't lose this. We're gonna add some more throughout the next couple days in here. We'll do some more stuff. I would be probably expecting maybe homework tomorrow or Thursday. I'm thinking Thursday this week we'll probably get another assignment. Basketball is. Good thing I don't. Mine doesn't.
Hey, Hawk, you have your board?
It is up here.
What a convenience.
I don't understand.